Okay, yeah, stop the music. Okay, so this is a lecture on trigonometric functions, section 3.5. Yeah, that's my cat in the background. And she doesn't like it when I'm talking to the computer. Okay, so yeah, I'm not doing anything to her, I swear. Okay, anyway, okay, so we're just going to go over quickly how to derive the derivative. We're going to talk about derivatives of the 6 trigonometric functions: sine, cosine, tangent, cotangent, cosecant, and secant. And again, this is the derivation is not something that you need to worry about. And I know in the past I said if you're a math major, you should be interested in this, or as a math, I have lots of degrees in math, and off the top of my head, I couldn't do it. I would have to review my notes. Uh, so I don't think it's something as a math major you even have to memorize. It's probably something you should want to be interested in. Okay, so we did learn some of these limits a long time ago. Limit of sine theta over theta is 1, and limit of cosine theta minus 1 over theta is 0. And that sine theta over theta equals, limit of sine theta over theta equals 1 comes up a lot over the course of your calculus career. And then you probably learned the summation formula for the trig functions in your trig class. I'm sure at some point you might, now that you see it, you might remember it, or maybe you do remember it. Sine of alpha plus beta is sine of alpha cosine of beta plus sine of beta cosine alpha. And so now let's just go directly to the definition of a derivative. We're going to take the derivative of sine, and you can see that we're right here. And okay, so if f of x is sine of x, the derivative is the limit as h goes to 0 of sine of x plus h minus sine of x over h. And so that's, now we're going to use that summation formula, and you get sine of x cosine of h plus cosine of x sine of h minus sine of x over h. And then we're going to break it up into 2 parts. And so we actually use the first and third term. It's like this first rational expression here, and then we have a second one. So that first rational expression uses sine of x cosine of h minus sine of x. And then the second rational expression it's cosine. It's really not a rational expression. I should stop using it. The second expression is cosine of x sine of h over h. And so we just factor out, so out of that first expression, they left kind of thing that looks like a fraction, factor out sine of x, you get sine of x cosine of h minus 1 over h. And look, there's that limit that goes to 0 as h goes to 0. And then we have this second term, cosine of x times sine of h over h. And we know that the limit as sine of h over h goes to 0 is 1. So basically it's saying if the radian is really small, like the second coordinate is when h is really small, the second coordinate on the unit circle is really very close to the radian. Okay, so anyway, so what happens is that the first term drops out because cosine of h minus 1 over h goes to 0. And then sine of h over h goes to 1. So when we evaluate the limit of sine of x plus h minus sine of x over h, oh, look at that, turns out to be cosine of x, which is, I mean, I don't think it's obvious. It's interesting. It's interesting if you like math, I guess. I don't know. I think it's interesting. Okay. And then we can actually do the same thing for cosine. And it turns out the derivative of cosine is minus sine. Now, I have to tell you, since when I first learned this, not just for, sometimes I'll forget, okay, which one is it? I know the derivative of cosine involves sine. I know the derivative of sine involves cosine, but which one has the minus sign in front? Sometimes that would give me problems. Then, well, look, just look at the graph. So there I kind of have this kind of crude graph that I drew by hand right here at the bottom of page 2. And what you see there, okay, so that blue part is sine, the graph of sine. And students, I made a mistake here. It's the other way around. That wouldn't be very good, would it? It's the blue is cosine. The blue is cosine. So the blue is cosine. So let me go back to, so the red is sine. So the red is sine. The red graph is the sine function. see if I can get the blue there. And then the blue is cosine of 0 is 1, and sine cosine of 0 is 1 and sine of 0 is 0. Okay, so that's a lot better. That would have been bad. Okay, so but look at cosine. So we know when we go from 0 to pi over 2, well, the function is going down. The cosine function, the blue graph goes down. So we know its derivative is negative, right? And we see that the sine function from 0 to pi over 2, it's above it's above the line y equals 0. So the sine function is positive. So we we know that the derivative of cosine, just looking at the graph, I know that the derivative of cosine has to be negative because the tangent lines are going down, right? The graph goes down as we go from 0 to pi over 2. So if I said, so if I'm guessing, okay, now what is this? Is the derivative of cosine sine or minus sine? So if I said this, if I said the derivative, this would definitely, I'd be saying that the derivative, so if I said the derivative of cosine is sine, I'd be saying that the derivative of cosine is positive from 0 to pi over 2, where we know it's negative. So there's got to be a minus sign right there. Okay, so maybe that wasn't a problem for you. It's a problem for me. Okay, so but this helps a lot. If I think of the graph, I know that the derivative of cosine is minus sine. Okay, so and then we can just use the product rule and the quotient rule to get the derivatives of the other trig functions. And then we'll look at a couple of problems in a minute. Yeah, so you can actually, tangent is sine over cosine. So we can just use our friend, the quotient rule. And yeah, and just get, yes, and get the derivatives that way, right? So we know that tangent is sine over cosine. Yeah, so you take the derivative of sine as cosine multiplied by the denominator, and then minus the numerator, which is sine, times the derivative of the denominator, which is minus sine, all over cosine, the denominator squared. And then you simplify, you get cosine squared, minus minus, you get plus sine squared, and we absolutely have to know this identity. Cosine squared x plus sine squared x equals 1. It's the most famous identity in trigonometry, or the most useful and the most widely used. So I think we all know that one. And also remember, cosine and sine are the first and second coordinate on the unit circle. So of course, cosine squared x plus sine squared x equals 1. So it turns out that the derivative of tangent, well, there we get 1 over cosine squared, but remember 1 over cosine is secant, right? That's how we define secant. It's 1 over cosine. So the derivative of tangent is 1 over cosine squared, but we simplify that by saying it's actually secant squared. And then you can get similar derivatives for the other functions, like the derivative of cosecant. Now you just, you would actually use the product rule. And so we actually get all the six, so we really quickly went through, derived the derivative of sine, and then we also mentioned the derivative of cosine. We did use the quotient rule to get the derivative of tangent. And you can verify this. The derivative of cotangent is minus cosecant squared. The derivative of secant is secant tangent, and the derivative of cosecant is minus cosecant cotangent. And so notice the one thing, students, that all the co-functions like cosine, cotangent, and cosecant have the minus sign. So maybe that's another way of remembering it. So yeah, there's these 6 trig functions. 3 of them have a minus sign in front. It's all the co-functions that have the minus sign. Okay, so so let's we can actually look at a couple of problems here, and then I have a couple more from my lab. Okay, so like their example 1, we want the derivative of t cubed. Maybe I can make that. God, it is really very small. Let's try 150. Okay, so let's just look at a couple of the. Let's see, where was I? Right here. We're going to look at the derivative of t cubed sine of t. Oh, so again, we'll just use our friend, the product rule, right? So you take the derivative of t cubed, and the derivative of sine is cosine, and then you take the derivative of t cubed, which is 3t squared, the power rule, and you multiply that by sine of t. And typically, students, when you're multiplying a polynomial times a trig function, put the polynomial in front like that, just kind of like we have here t cubed. This is how the original function was written with t cubed in front. So yeah, when you're so I would not write sine t times 3t squared. I would write 3t squared sine of t, and definitely any constants you want to put on the left. And then if you want, you can actually, I'm not sure it's really necessary, you can factor out t squared. Okay, let's look at another one that's kind of interesting. So students, we are eventually at some point going to learn a rule called the chain rule, which will maybe make our lives easier. You'll have to tell me when we get to it. But we don't have that right now. Okay, so what we see there is that f of x, let's take the derivative of cosine squared x. So with the chain rule, once we know the chain rule, we'll probably just use the chain rule to do this, but you don't have to. But look, isn't cosine squared the product of two functions? Cosine of x, cosine of x. So let's use the product rule. So we'll take we'll take u times the derivative with of v there. So cosine of x, the derivative of cosine is minus sine. And then once again, it's cosine of x. Now let's take the derivative of u, but look, it's the same, u and v are the same. So add them together, you get minus 2 cosine x sine of x. Or, and then, we're using one of our, maybe it's our second favorite trig identity. 2 cosine x sine of x is sine of 2x. That's actually a very common identity. 2 cosine x sine of x is sine 2x. And if you actually expand sine of 2x with the addition rule, sine of x plus x, yeah, you're going to get 2 cosine of x sine of x. So that's another one of the more important trig identities. 2 cosine x sine of x is sine 2x. And I'm sure we use it a lot more later in the year, and probably in Calc 2 as well. So let's see, is there another problem? Because I have a couple of problems I'd like to look at from my lab. I think there was one I wanted to look at, and I have one in my lab. Okay. Okay, so let's look at this. Yeah, this is example 6 right here. And then I have another one, I think, in the from the, oh yeah, let's look at 6 and 7, then we'll go on to the MyLab problems. Okay, so let's find this, what's called the second derivative of cosecant of v. So that means you find the derivative, and then you have to take the derivative twice. And it can get, especially with these trig functions, it can get kind of long. And I guess I'm trying to avoid the word tedious, but it can get, you just have to be careful. And that's the one thing about calculus students. And a lot of you have asked me questions over the last couple of days, and I've made a lot of simple errors, and it's time consuming just tracking down these errors. So these problems are time consuming and they get kind of long sometimes. Okay, so let's take the derivative of cosecant. So remember, that's a co-function, so it's going to have a minus sign in front, and so the derivative of cosecant is v is cosecant v cotangent v, and again you can get that using with the quotient rule 1 over cosine. Okay, but you can just memorize it or just write it down on a sheet of paper when when you're taking a test. Now or next semester. Okay, so now we want, but what we want is the derivative of this function right there, minus cosecant v cotangent v. So that's it's the second derivative of cosecant of v. And we'll be doing a lot with second derivatives eventually in this course. Okay, so the derivative, so let's just use the product rule. We'll take the derivative of v first, and then the derivative of what's labeled u. So it's cosecant of v, and the derivative of cotangent of v is minus cosecant squared of v. Remember, cotangent is one of the cofunctions, so it's got a minus sign. And then we'll take the derivative of u, so it's cotangent of v, and then once again, let's take the derivative of cosecant one more time, minus cosecant of v cotangent v, and let's simplify. So you get, remember that, so it's minus the expression, or minus the quantity, minus cosecant cubed of v, minus cosecant of v, cotangent v squared. And then if you just expand, and if you expand that, you get cosecant cubed of v plus cosecant of v plus cotangent of v squared. Okay, so So let's see, students, let me just show you something which I might regret doing here because it wasn't, this is not part of the planned itinerary. I just want to show you that there's this identity. The thing with a lot of these problems, especially when you're dealing with trigonometry, you'll see this if you actually, there are websites that will actually do these derivatives for you, but you get these wild answers because you can write a trig function in so many different forms or trig expression just by the use of identities. And so what do we have? Remember cosine squared x, I'm writing on the screen, so hopefully it's not terrible, is 1. And then let's divide both sides by sine squared. So you get cotangent squared of x plus 1 is equal to cosecant squared of x. Okay, or we get, so what do we get? We get cotangent squared of x is equal to cosecant squared of x minus 1. Okay, so now I'm going to, that's a square, so I know I'm writing on the screen vertically, which makes it hard, but it's a square there. So now let's just substitute that into here. We can actually simplify this a little bit. You're going to get cosecant cubed of v, and now you get cosecant of v. So I have to write it down below. So I said, maybe I regret doing this, plus cosecant of v, and then cotangent v squared is, what is it? Isn't that cosecant of v squared minus 1? And so what are you going to get, students? You're going to get cosecant cubed of v plus cosecant, let's see, cubed of v minus cosecant. Maybe that's not actually so much better, to be quite honest. Okay, so yeah, that's maybe not so much more exciting, but I just wanted to show you there's different ways of writing the answer too. So now you'd get 2 cosecant cubed of v minus cosecant of v. So maybe it's not as exciting as I thought. Okay, but I'm just saying there's just so many different ways you can write these trig functions. Okay, so we'll just drop that. Okay, so okay, so let's just do a couple more problems here. Okay, let's do example 7. Okay, so we want to write, this is kind of a fun problem. And again, this is what I mean, these problems in calculus get long, students. So I think chapters 1 and 2 are probably going to be a lot easier than I think the rest of the course. Not everything is, but I say not, I think the problems are simpler in terms of how long it takes to write out and compute the answer. Okay, so write the equation of the line tangent to the graph of x tangent x, where x equals pi over 3. Okay, so so what we have to do, we have to get the slope. We have to find the derivative and evaluate the derivative at pi over 3. And then we need the value of the function at pi over 3, right? Because we're going to get y minus y1 equals slope times x minus x1. Okay, so we know the function goes through pi over 3. So f of x at pi over 3, what do you get? So it's right here. It's pi over 3, tangent pi over 3, and tangent pi over 3 is just square root of 3, right? Sine of pi over 3 is square root of 3 over 2, and cosine pi over 3 is 1/2. Yeah, so that quotient, square root of 3 over 2 divided by 1/2 is square root of 3. So this function, f of x at pi over 3, the second coordinate is pi over 3 times square root of 3. Okay, so this function x tan x goes through that point right there. And now we'll get the slope, we'll get the equation of the tangent line if we could just find out the derivative and evaluate the derivative at pi over 3. But we're going to have to use the product rule. So yeah, now these derivatives get longer. You have to, that x tan x is now turning into a function with a plus sign in the middle. Okay, so let's first take the derivative of tangent. So you get x secant squared of x. And now let's take the derivative of x plus tangent of x. So the derivative of f of x is x secant squared plus tangent of x. And now let's evaluate that at pi over 3. And so what do you get? You get pi over 3 times 1 over, secant, we're going to evaluate secant squared x at pi over 3. Well, that's just 1 over cosine pi over 3. Now cosine of pi over 3 is 1/2, right? So secant of pi over 3 is 2. I'm not, secant of pi over 3 is 2. So secant squared of pi over 3 is 4. So the derivative of this function f of x at pi over 3 is pi over 3 times 4, and tangent of pi over 3 is square root of 3. So wow, what a derivative, okay, or what a slope. Pi over 3 times 4 plus the square root of 3. And now what's the equation of the line? So it's y minus y1 times the slope times x minus the first quadrant of pi over 3, or the equation of the line. We're not going to simplify by isolating y. It's y minus pi square root of 3 over 3 is equal to the slope 4 pi over 3 plus the square root of 3 times the quantity x minus pi over 3. So these answers, this isn't really long to do, but yeah, it's kind of not like a real elegant solution, maybe like we're used to seeing. So so let me let's just look at a couple of other problems right here. Okay, so a student had, hopefully I can open this up here. Okay, there we go. Okay, so so here we have, let's just, at least we can do one of these. Okay, so let's just find the derivative. This is actually problem number 18 from my lab. And so, and I use an identity here, and you don't actually have to do that, but it just shows you how, well, identities can make the problems look more, the solution look more elegant. If that's important to us. Okay, so it's a tangent of t divided by 3 plus 3 secant t. Oh, so of course we're going to have to use the quotient rule, right? So it's the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator, and then the denominator squared. Okay, so let's see. So the derivative of tangent. So well, first of all, since I factor out 8/3, right? I factor out 8 out of the numerator and 3 out of the denominator. So y is equal to tangent of t over 1 plus secant of t. And then, okay, so the derivative of tangent is secant squared. So the derivative, so it's secant squared times the denominator, 1 plus secant of t. And then it's the numerator tangent of t times the derivative of the denominator. Well, the derivative of 1 plus secant of t is secant of t, tangent of t. And then the whole thing is divided by the denominator squared, 1 plus secant t squared. And okay, so now we have to simplify. So we have to expand and simplify. So we get so just expand, you get secant squared. You know, secant squared times the expression 1 plus secant of t. So it's secant squared of t plus secant cubed of t, and then minus secant t times tangent of t squared, the whole thing divided by 1 plus secant of t squared. And since if you left it like this, I'm sure I would give you, I said, I think I'd probably, who knows better than me? I would give you full credit. I'm not expecting you to do this, use this identity. Okay, but remember that tangent squared t is secant squared t minus 1. Yeah, 1 plus tangent squared is secant squared. And so tangent isolates tangent squared, it's secant t minus 1. So we're gonna, so in our derivative, we're going to replace this tangent squared with secant squared t minus 1, and then once again expand and simplify. So we get secant squared of t, secant cubed of t, oh, now minus secant cubed of t, and now plus secant of t. Oh, and the secant cubes cancel. So what are we left with in the numerator? Secant squared of t plus secant of t, the whole thing divided by 1 plus secant of t. Oh, but look, we can factor out a secant of t out of the numerator. So we get secant of t times the expression 1 plus secant of t, the whole thing divided by 1 plus secant of t squared. And then, so just cancel a factor of 1 plus secant of t out of the numerator and the denominator, and you're left with 8/3 secant of t all over 1 plus secant of t. And, but as I said, students, let's go all the way back up here, and that's also a correct answer. The one where I don't actually simplify it. And I have this actually online, I think. Let's see here. Let's see. Can we try another one here to do? Okay, yeah, so here's another one from my lab. Again, it's another second derivative problem. Now, I have to tell you, I get a little frustrated with my lab. You get these like, they ask you a couple, you solve a problem, they ask for a similar problem. This one was frustrating me because I thought there was a big difference. They said, here's a similar problem, but they weren't always that equal. And so I was trying to get the harder, I mean, I saw it earlier. I kept trying to get it to generate a harder problem, but I couldn't. The harder problem would be finding the second derivative of secant, cosecant, but okay, let's just do this. Okay, okay, so we're going to take the derivative of the second derivative. So we take the derivative of the derivative. We're going to take the derivative of the derivative of cosine of x sine of x. Students, if we knew the chain rule, which we're going to learn eventually, if we use an identity and use the chain rule, eventually what we'll do is we'll see that this is, well, we know that this is equal to sine of 2x all over 2. And, and then we'll learn a fast way of just starting directly with sine of 2x. Of course, you have to see that you have to be familiar with with the identities to make that, to go from cosine of x, sine of x to sine of 2x over 2. But that's for the future. This is like coming attractions. You're at the movies, and the coming attractions start, and oh my God, coming in May of Star Wars 10 or something. I never made it past Star Wars 3. I'll be honest. That was no. I did see Star Wars 4. I think I can't remember. Okay. Anyway. Okay. So okay, y equals cosine of x sine of x. We want the second derivative. See the two dashes in the y? It means second derivative. First, find the first derivative. I actually took the derivative of cosine first and then multiplied by sine. And it really doesn't matter, students. The student was asking me about this. Does it make a difference? And I'll be honest, sometimes I don't even think about it. Okay, okay. So derivative of cosine, which is minus sine, it's a cofunction, times sine, and then cosine times the derivative of sine, which is just cosine. And so you get minus sine squared x plus cosine squared x, or cosine squared, so you get y prime. The first derivative is cosine squared x minus sine squared x. Okay, so now, so students, now we want to take the second derivative. Again, let's do this now, and then we'll really appreciate the chain rule, which I forgot what section it's in. But right now, we haven't talked about the chain rule. And so we're gonna find the derivative of cosine squared of x using the product rule. So cosine squared of x is cosine of x, cosine of x. And sine squared of x, of course, is just sine of x, sine of x. So let's just use the product rule on each. So let's take the derivative of cosine squared of x, cosine of x. So the derivative of cosine is minus sine, then plus cosine of x, and then plus cosine of x, and then take the derivative of cosine of x again, you get minus sine of x. Okay, and now the same thing for sine of x. Okay, so, and I've got, remember there's a minus sign in here, so that's why I have this minus here. So, so the derivative of sine is this cosine times sine of x, and I distributed the minus sign. So, so then it's the derivative of, then it's sine of x times the derivative of sine of x again, which is cosine of x. So what do we get here? We get, oh, look at all the terms have minus sine cosine of x, minus 4 cosine of x sine of x. That is the second derivative of, so the second derivative of sine of x cosine of x is minus 4 cosine of x sine of x. So that's pretty interesting, students. Okay, anyway, so much for that.